So just reading this, in your early mathematics career, you learned about 0 and 1. Later, you learned about pi. For most students, pi is the first example of an irrational number. As you advanced, you might have learned about this imaginary number, I, the square root of -1. We didn't spend a lot of time on that in polynomial world, but I is an imaginary constant. So these are important numbers in mathematics, and now E has made the list. There's an equation that you may encounter in advanced mathematics, which is written this. It relates the 5 important numbers, E to the I times pi to the 0 power equals 1. But anything to the 0 power is 1, so it's not that interesting. But where is E used? E is used when we're doing compound interest. So I'm just going to write C video, right? But the video, as we approach bigger and bigger values, the value approaches about 2.7, right? That was the compound interest as we did more and more, right? So n was like, they did 12, they did 365, they did 52. As n got bigger and bigger, the value for our interest approached 2.7. So find E on your calculator and tell me what E is as a value. So go to second E. It's above the division sign on your calculator. So it's a key you probably haven't used before, but we're going to need it for some of our calculations in log applications. So when you push E, you should get 2.718. Just like if you press pi, you get 3.14. It's a number that's stored in your calculator. Does everyone see where that is above the division sign? The other button that you have is above the natural log key, e to the x power. So if you wanted to do like e squared, you could do e raised to the second power, and it'll square the number for you. So there's 2 different places where e is on your calculator. So it's about 2.71828. It's a non-repeating decimal. It's irrational. It goes on forever, just like pi, 3.14159. You had to memorize all those values of pi. So I just want you to know that E is a constant. E is a value, 2 to the 2.7. And then E is not the E used for email or electronic, or it's not Einstein's E equals mc squared, right? E is referred to as Euler's number. It's unclear whether he used E to name it after himself or it was just the next constant he had yet to use. So I just wanted you to find E squared on your calculator and E to the negative first on your calculator. And I want to show you that you can graph E to the x. E to the x is the same as 2 to the x or 3 to the x or 4 to the x. So did everyone find E squared on your calculator? So E squared is about what, 7.39? Was everyone able to find that? And then try e to the negative first. So what's the reciprocal of e? So 1 divided by 2.7, use the negative first key. There's also a shortcut negative first key right here. So if you don't want to raise it to a power, you can just hit the second E button and then that x to the negative first power. 0.37 about? 0.37. So if you were going to sketch the graph, we know that anything to the 0 power is 1. So 0, 1. We already know that E is 2.7. So I go over 1 and up 2.7. We already said E squared was 7.39. So 7.39. And we know that it's a fraction or decimal 0.37. So there's E to the x. It looks very similar to 2 to the x, and it has an asymptote at y equals 0. Right, so we're just using these couple points. This was 2, 7.39, negative 1, 0.37. We know that we go through 0, 1. We know that we go up to 2.7 because that's the value for E. So what would this change do? What is this transformation rule? E to the negative x power. Yeah, so we're just going to take those points and flip them the other way over the y-axis. So we're still practicing our transformation rules, just with a new function because E is just a number. So I can graph it. So still y equals 0. So all I did was I flipped that graph over the y-axis. And then what does that last part do? E to the x plus 2. Where would that shift the original function? To the left by 2. So you're going to take each of these points and shift them left 2. So left 2, left 2, 2.7, 7.39 about. Right, so I shifted left 2. So my asymptote was still at y equals 0. So just being really familiar with those transformation rules. I'm not going to have you graph E on your test next week. Today is just kind of another introduction in person to the letter E. You may have a compound interest question, so that's using the E button on your calculator. And then just at the bottom, it says, what interesting facts about the graph of E to the x were stated? So the function y equals E to the x, the gradient is really the derivative. Derivative is y equals E to the x, and the area under the curve is y equals E to the x. So anywhere on the curve, you can find the derivative using that function. Anywhere you can find the area under the curve using the same function. So when you get to calculus, you'll use E as part of your language. So this is just an introduction. E is a number. We can find its value. It relates to growth. All right, so that's just an introduction to what E is. And then I wanted to show you some compound interest problems that you may or may not have seen any of these in Algebra 2, just depending on how much your course got abbreviated. So I was going to do some with you and then have you finish up with the guided practice. So there's 309 that I wanted to do together, and then some 309 guided practice. There's just 2 questions you're going to do on your own, and then you might have time to start the homework 311. 310 is we're going to do after during our virtual time. So, all right, so compound interest. Does anyone have questions so far on E? Sorry, I can't take you for a walk today. We're going through here. So compound interest allows you to earn interest year after year. In the old days, people had to sit down with simple adding machines to compute interest. So compound interest was performed annually. Can you imagine if you have 1,000 customers at your bank and you have to compound their interest every single month, right? With a simple adding machine, you don't have the software or the calculator, so they could only do it once per year, if that. Later, with better calculators, banks started attracting business by offering compounded quarterly or compounded monthly. Hey, what do you need? Sure. Discrete calculations can be performed by dividing your interest rate by the number of times it's compounded, just like you saw in that video. So in other words, they give you less interest, but they compound it more times. So here is the formula you're going to get on your test. I'm not expecting you to memorize that, but you will not be given this information. So you have to know what P represents, what R represents. R stands for interest, right? So here's some practice using that compound interest equation. Find which value is the largest. If I compound annually for 3 years, or if I compound quarterly for 4 years, what's my better result, right? So I take $4,500. I'm investing it. So that's my P value. A stands for amount in the account. I'm investing $4,500. Does this feel like something you've done before, any of you? You did compound interest in Algebra 2? Okay. Some people did. So 1 plus, so what's the interest rate? Now it says up here, the interest rate needs to be expressed as a decimal. How do I express 5% using a decimal? 0.05. And it's being compounded annually. Annually is only 1 time per year, so I really don't even need to split up that 5% interest. I'm just going to write the 1 there to represent the number of times we're compounding. The exponent is going to be how many compounds? I'm only compounding 1 time per year times 3 years. So my exponent is 1 times 3, which is 3. So you're going to type this into your calculator and see if you can get the right answer. Keep all of your parentheses. Do it all in one entry so that you don't mess up the order of operations, and see if you can calculate the correct amount of interest or the correct ending value for the account. So if someone gets it, maybe you can tell me what you get, because you typed something incorrect. 5209 and what, 31 cents if I round to the nearest penny. So now what changes in the second part? I'm still investing that $4,500. So the 1 represents, hey, I'm giving you back your original investment with interest. I'm still getting 5%, 0.05, but this time they're compounding quarterly. There's 4 quarters in 1 year. It represents every 3 months. So I need to divide my interest rate over those 4 quarters, but I get more compounds up here in the exponent. I'm multiplying the 4 compounds times the 4 years. So I actually get compounded interest 16 times in that bank. So you're going to see what that amount comes up to. So you're changing your equation a little bit. 0.05 divided by 4. And then you're raising it to the 16th power. This comes out bigger than what you had before, but it's mostly because there's 4 years of time. So you had more compounds and more time. Hopefully you'd get more money. Did someone get an answer? What'd you get? Yep, 5489 and 50 cents, right? If you now round to the nearest penny. So who can I troubleshoot for that one? Do you want to set up another one together? Or do you think you can set up, yeah, do another one together? All right, so number 2, I have $10,000 to invest. They're going to give me 3.5% annual interest. Find which balance, it should say balance, is the largest. Do I want to do 6 years at 6 times per year, or 5.5 years, so fewer years, but compounded more times, compounded monthly? So A stands for the amount in the account. I'm investing $10,000. I get my money back, so that's the 1. Plus, what's my interest rate? How do I express 3? Yeah, point, you can move the decimal 2 places, so 0.035. How many times does that get divided up? 6 times per year. So I'm going to divide my interest rate by 6 over those 6 times. And how many times do I compound? 6 times every year times 6 years is 36 times I'm getting compounded interest. And then see if you can set up part B on your own this time. Sure, did you send me a pass? Okay. What'd you get? 10,000. 1 plus 0.035 divided by 6 raised to the 36th. Yeah, 12,329. 12,329 and 26 cents. Did anyone need help typing that in and are you getting the right answers on your calculator? Because that's what you want to really practice, making sure that you know how to type it in properly. All right, so see if you can set up those last couple, and then we'll talk about compound interest on the back when it's continuously compounded. So take a minute. I'll put up my answers in a minute for those. Pause. So we've got, you were going to do B and then part number 3. Number 3 is a little bit small down here, so I'll zoom out a little bit. Kind of hard to read. 14,257 and 61 cents is what that says. On to the back page. I thought it was just the guided practice, but this is the rest of those notes. So this is what if you want to figure out how much you have to invest. So Donovan's offered a $50,000 signing bonus in 4 years when he graduates from college. If the company that wants to hire him is expecting to earn 4% annual on its money, how much should the company invest now so that they can pay him his signing bonus in 4 years? So we're solving for our p-value. So we do not know how much to invest in the bank, but we know that we owe him $50,000 in 4 years. So we're going to fill in the rest of the equation. We get 4% annually on its money. And so we need 4 years, 1 times 4. How are we going to solve for P? I need to get P by itself, right? So how can I move? This is just a number. So when I type this whole thing in the blue into my calculator and hit equals, I'm going to get a number. I can take that number and divide it to the other side of the equation to solve for P. So then I'll know, do I have to invest $20,000? Yeah, this is being multiplied right here. So the opposite of multiplication is division. So you're going to take your interest, the parenthesis 1 plus the 0.04 raised to the 4th power. You're taking basically your interest and dividing it to the other side of the equation. And it's still a pretty big number they're going to have to invest. By that answer. Yep. So this gives you about 1.169. So you're taking 50,000 and dividing by your answer. So I got that they would have to invest $42,000, 42,740 now. So they're not going to pay him the bonus, but they need to plan on having that reserved for him. And so if they invest 42 now, they'll have the 50,000 in the account for him after the 4 years. And some companies will figure that out. How much do we have to save now to give our bonuses so it's going to grow over those 4 years? All right, so the other type of interest formula, I would give this to you on your test. Anytime you see the word continuous, you're going to use this formula with E. So it says, notice our continuous formula looks a lot like the formula above. Without going through the derivation, you should be able to begin to see how E ends up in the formula, because that's what that guy on number file was talking about. The more times you divide N and then you raise it to the compounded power, it's about E, 2.7. So just this is using the other compound interest formula if you've never used it before. If you deposit $4,000 at an annual interest rate of 6% compounded continuously, anytime you see the word continuously, you're using this formula. So how much do you have after 1 year? So my formula says the amount is equal to your principal, what you invested, 4,000, times E, E is on your calculator as a constant, to the RT. R is interest rate, so 0.06, and T is time. So I'm going to do 0.06 times 1 on my calculator. So you're typing it in using the constant for E. Don't abbreviate or don't round E. So Eric, we're on the back page of the 309. We're doing the continuous compounding now. Yep. So 42, 47, 35 is what you should get when you type that formula in to come out on their calculator, because you have to type it in to know if you are going to be able to do it correctly. So the only difference with 10 years, did you know that you can just arrow up and reselect that whole formula again? If I just arrow up and hit enter, now I've got that formula on my screen. All I have to do is multiply by 10 in the exponent, and I could just, I don't have to type it all in again. So if you just arrow up, you can grab the formula before. So that one would be 72, 88, and 48 cents, right? The only thing that changes is the 10 years in that year position. So number 6 is comparing continuous with not continuous. So they both have 1 year of interest. You have $2,000. You have an interest rate of 9.5%. So this one is continuously for part A, and this is compounded annually in part B. So, how many dollars are you different by? It's only 1 year, so it's not going to be a whole lot of a difference. But you take your principal, E to the interest rate times time, and see what you get. And then see if you can set up the annual formula for part B. So I got for the first one $21.99 and 32 cents. That was my continuous interest. Annually is going to be right up there. 2001 plus, we're still doing the 0.095 divided by 1. And then we've got 1 compound times 1 year. So how many dollars are we off by? Or just cents maybe? 2190 is what you should get. So we differ by, well, still $9. $9 after a year is still a decent difference. It's the same interest rate, right? The only difference was how many times they were compounding. All right, see if you can figure out how to set up number 7. How much money has to be invested? So we're looking for P, right? If you have a goal of $150,000 in your account. So put P in your equation, and it says continuously. So that tells you which formula you should be using. And remember, you are going to calculate this amount on your calculator and then divide that amount to the other side to get P by itself. So financial advisors do this all the time. You have a goal of what? 500,000, 2 million. What do you need when you retire at the age of 65 or 68? How much are you putting in after every paycheck monthly? They can give you the, this is how much you're going to have in your retirement account if you put aside $100 a month for your entire career. Will you have enough to retire? You figure in your Social Security, you figure in any other retirement things that you're going to get. That's what a financial advisor will do. They'll tell you if you're on track to retire at age 55, maybe. That's your goal. So if you like the idea of, math, compound interest, money, I mean, there are a lot of lucrative careers managing other people's money for them. $100,548.01 is how much you need to invest. Does that sound right? It's only 10 years. You're gaining $50,000. It's only a 4% interest rate. So that's a decent return on your money. If you were like in the stock market, hopefully it would go up with more than that, between 8 and 10% interest. All right, so that was compound interest. You are going to try, if you haven't yet, the 2 applications on the next page. And that we should have done in about 5 minutes. So I'll come check your answers to those in about 5 minutes. And then I also want you to just pull out of your binder and put it at the front, page 311, because Wednesday is a long ways away. But you need to do 311 as your assignment for Wednesday. You've got 4 days to get it done. There's 3 questions that you need to cross off, because 311 is basically the review for your test, except we have not covered, where did my review go? Lost it. Okay. The ones that I want you to cross out are the ones about the inverse, 11, 12, and 13 on the back. So we do not need to do 11, 12, or 13 on page 311, but pull 311 out. It should be in the front of your binder so that you remember you're going to do those as a review. That way, Wednesday when you come in, you're not cold, because Wednesday we're going to do the team test on exponential functions, right? For a test on Thursday that's going on quarter 3. So you've got this as a review between now and then.